All right, time for a status update on the Songline processor implementation project thing going on, because I got like 1 week of summer vacation left. It just started like a week ago, but so down to the end game of this. So let me show you some of the aspects of this build. So here's the box it's going in. So this is a Victorian sewing box that Karina bought me for, I believe it was birthday last year, um, and it's circa late 1800s probably, but in pretty good shape. She cleaned it up nicely. It's got the little handle on the top, nice brass, and a lock here that that basically works. And so if you open it up, that's the inside. Now she redid the inside. She lined it with this fabric, which is fabric from Peru, apparently, and some trim from Joann's. And so the only mod I had to make to this box was in the corners here. You can see maybe these little 4 pieces of 3D printed plastic. These are nailed into the side of the board with just the right length nail to almost come through the outside, but not quite. And these are really just to hold a faceplate down, a plexiglass faceplate. So it'll screw down onto these 4 pieces, and these are printed to hold a little M5 nut underneath. So I'll come down with a bolt on top, and that'll hold a faceplate in. And so this whole thing will enclose the assembly I'm about to show you, and you can close the top and lock it and carry it around, or you can open it up and use it. So here's the faceplate that goes down against the bottom of the box, and so there's notches cut in here that will accept those bolts to hold this down to the bottom of the box. And then it's basically a Raspberry Pi, right? So that's a Pi 4, the real workhorse. USB cable coming out, which has been cut into to send a signal to a power control board. And then underneath is the power control system. So this board right here, and I've talked about this elsewhere, but it's really just a way to do a power switch. So once you apply power to the system, you can cut the power, and the power will continue to be delivered to the Pi, but the Pi can send a signal saying that it is shut down, and that will terminate power to this relay, which will cut the power to the whole system. So you can turn it on, and then when you turn it off with the switch, the system continues to run until it does its orderly shutdown. And then this board up here is the Songline processor interface board. And so this was the thing that I designed and had made a few weeks ago. And it basically, takes a series of analog inputs. So these 4 inputs come from potentiometers. These 4 inputs come from just, a pair of positive, negative, and then 8 analog outputs. And so it's the interface board to the Raspberry Pi, and it connects through, a 40-pin connector on the bottom with a few tweaks. For example, when I boot the Pi, if I have my analog input set all the way to 5 volts, it kills the 3.3 voltage coming out of the Pi. So I broke the pin that normally sends 3.3 volts out, and I have a 3.3 volt regulator sitting on this board that brings 5 volts down to 3.3. Details, right? But the bottom line is this will sit in here, and then this is a self-contained assembly. So there's 2 LEDs. There's an LED that lights blue when you apply power to the system. There's an LED that blinks red when it's going down, and then when the LEDs are off, it's all off. So I made a little LED holder that these lights will go inside, and this will get affixed to the top. And when the system is activating an LED, you get a nice little bar of light showing through this top plane, so it doesn't blind you, like an LED might, but it will make it clear. And so I'm going to add a third LED that comes to my one unused output port, and I'm going to keep that, as whatever I decide to do in code, but I think I'm going to use it to indicate the depth of the queue, because I'm starting to find some issues with the queue overflowing. So what I'm going to do is blink n times per second, where n is the number of things in the queue. So the faster it blinks, the more full the queue is. If it blinks very slowly, you know the system is keeping up with the input events and so on. Things to play with. All right, so this board gets, you know, bolted down to the bottom on the inside of that case, and then you've no doubt noticed these little stands here. So these are 3D printed octopus arms. It's a little hard to see the tentacles here, but there we go. Yeah, so I found on Thingiverse, somebody had an octopus arm coat hanger that they had come up with, you know, to attach to their door. So I hacked that up and just took out the arm piece, added a base that will screw into the plexiglass on the bottom, and then added a top piece that will hold the control panel with, you know, a 6-sided opening underneath to hold an M5 nut. And so 4 of those get bolted down onto here. These are white. I reprinted them in glow in the dark, so, you know, bonus points for that. So these will hold up the top face panel, and then basically from these contact points I'll run connectors to the items on the control panel, and this is the main USB power input, and that will go through a little grommet like this, and it'll get hot glued underneath, and then you have a nice sort of interface piece like that. So so the last piece of this is the control panel, and this is not fully populated yet, but there's a basic idea of what it looks like. So you know, 3 rheostats for coarse grain modification, 1 multi-turn. It's a 10-turn rheostat that you can use to dial in more precisely what sort of input voltage you want. So those are 4 inputs that you can, under software control, wire up to say, hey, let's you know, drive this on this cell's, you know, western side, and so on and so forth. And then, you know, a series of knobs will get put on those. So those are 4 inputs that we can choose from. We'll have 4 additional inputs here. These are just 1/8" jacks, and then 8 outputs over here that we can, you know, plug in an 1/8" jack as we wish. And this is where the USB C plug-in will go. So there's the faceplate there, and this is a 12-position selector knobs. We'll throw a knob on top, and this will choose any of these 4 inputs or 8 outputs to be sent to this meter, and this meter will show you the value of that. So in addition to, you know, hooking up outputs directly here through 1/8" jacks, you can also just locally monitor what an output is doing. So if you want to, you know, build a multiplier, you can dial in 2 numbers here, choose the output channel on this, and see the product. So we'll do demos of all this once everything is together, and we'll look at the software also. And then, of course, you know, the best part, this is the power switch down here. So it's you know, just an old cabinet key, and you plug that in, and when you turn it, that will turn the system on, and then if you turn the key the other way, that'll turn the system off. And the whole point of the power control board is when you do that and turn the system off, it doesn't cut power right away. It signals and eventually shuts down the system in a calm manner. So that's the basic status right now. So lots of 3D printing, which is always fun. Printed some washers to you know, keep this multi-turn unit from turning where it shouldn't. Printed the control box for that, the grommet for the USB port, and of course, you know, the glow-in-the-dark octopus support legs for holding up the top piece. And just have to, I'm reprinting the LED box to hold the LEDs all the way in, and then do a bit more drilling, put everything together, and we should be good to go. Should be a nice build when it's all put together. So anyway, that's a bit what I've been doing. More later. Thanks.